Unit 10, Lesson 4, I can solve for segments of intersecting chords by using similar triangles. So we're going for segments this time, not angles. Let's go ahead and do a mini investigation. We're going to sketch two intersecting chords over here to our right. I might do this one. I might do this one. I'm going to label them PQ and RS, intersection point T. I'm going to sketch in PS and RQ. So this here's PS, here's RQ, and we can see that we made triangle 1, triangle 2 in the process. So here's my goal. I'm going to show that these are similar, and if these triangles are similar, then the sides, in this case this segment to this segment, this segment to this segment, and this one to this one, would be proportional. That would allow us to use cross multiplication and help us find relationships. So why would these be similar? Well, by vertical angles, you know these two angles are congruent. The next thing that's interesting is if you turn the light on angle P right here, it intercepts arc SQ. If you turn the light on angle R, it intercepts arc SQ. So these are both inscribed angles intercepting the same arc. These need to be the same. This is half of this here. This angle is half of this here. They're both half of the same thing, so these two angles are the same. They're congruent. I can stop right there and just say by angle, angle, these two triangles are similar. Or you can go one more step and say angle S intercepts arc PR and the inscribed angle Q intercepts the same arc. They're both half of that arc, and since they're half of the same thing, they must be the same angle. So these are two similar triangles, so I can come down here for a moment and I can say a few things. I could say the different angle pairs that happen to be congruent. I'm going to skip that for time and just go straight and say the triangle PST up here is similar to triangle RQT right here by angle, angle similarity. So now that we know these two are similar, we can write a proportion. So for example, we're really looking at these two chords. That's what we care about originally. If you look at these two, how, for example, would this segment relate to that one? Or this segment relate to this one? And so I can come down here and say, well, for example, between this green angle and T, between this green angle and T, so this side here is similar to this side here, right? They're proportional. So I can say, for example, PT is going to be to RT, so kind of triangle 1, triangle 2, as ST would be to QT. Those are the corresponding sides. This side again is between this angle, green angle, and T. Here's another green angle and T. That's why they match. And then these match here between the pink and T and the pink and T. So that's kind of interesting. We were able to set this relationship up all because we could show these two triangles were similar. So how does that help us? Well, from now on, when we get a situation that looks like this, we're going to be able to say this segment is to this segment as this one is to this one. And that's going to be a really nice relationship for us to be able to use cross multiplication for. So if I move to my other side, we'll finish up this relationship and then look at two others quickly. The length of these intersecting chords, the relationship as we'll summarize it. We're going to say that similar triangles means we can write a proportion. And we don't have to create the triangles every time. And some might say, do you have to pretend like these are the triangles here, or could I have made them here? And it works either way. It really doesn't matter. But if you consider this segment right here, A, then this one right here, B, this one over here, C, and this one, D, the nice part is you can kind of put little fraction bars in there and then think of these as your proportion. So A over B is equal to C over D. And if you had done it the other way, you would circle them this way and this way, it actually would work out to be the same thing. It's not a problem when you cross multiply. You'd see both would be the same. So these are the annotations you want to follow, all because of the mini investigation we did before. Here are two other quick relationships. When you have congruent chords, so for example, if this chord is congruent to this chord, then you know that this arc right here is congruent to this arc right here, that are intercepted, so to speak, or kind of walled off by the congruent chords. So if we have congruent chords, then the arcs are congruent. If these arcs are congruent, then you have these two chords congruent. Works both ways. And finally, my favorite one, if you have a chord right here, AR, and it happens to be perpendicular to a radius, some cool things happen. First, you can look at it and probably guess that this radius bisects the chord. It also happens to bisect this arc over here. So the radius is perpendicular to a chord. Then the radius bisects the chord and arc. We'll be able to play around with this later on. You can make some right triangles in here if you were to add another radius here. And you can play with this right triangle in Pythag and all sorts of things. But this relationship here, the radius bisects the chord and the arc. So let's go and try and apply these three new ideas. So here's the first one. We're trying to solve for x, okay. And the easy annotation on this, two chords intersecting in the circle. You kind of set up your two ratios and say that they're equal. We can go in and cross multiply. Some people want to reduce first, and that's great. In this case, we can't. So you get 3x is equal to 45. Divide both sides by 3, and you're looking good. If you had tried it another way, if you don't believe me, it's really important to check it out for yourself. 9x, 3, 5. What happens if you would circle them this way? Well, if we try it a different way, let's see what happens. 9 over 3 and the x over the 5. So 9 over 3 and x over 5. Cross multiply. Sure, you could have reduced there, but let's stick with it for a second. 3 times x is equal to 9 times 5, which is 45. You can see we're at the exact same spot. So that's really nice. Either method works. This method over here, the relationship we talked about, look how the chords are congruent. Therefore, what do we know about these two arcs? They're going to be congruent as well right here. So I can just say 2x is equal to 100, or x is equal to 50. Finally, this one's a little harder. Circle P has a radius of 13. So this entire segment here, PL, happens to be 13. RA happens to be 24. But here's the good news. If this is a radius and it's intersecting a chord that happens to be a perpendicular intersection, then you know the chord is bisected, and so is the arc. So if RA happens to be 24, that means this segment is 12, and that segment is 12. So let's go answer the questions. The measure of angle, arc RL, just this right here, is 65. What is the measure of arc A to R? Well, if this is 65, so is this. Therefore, the measure of arc AR is going to be these two together. and that's going to be 130 degrees. Find the distance from P to F. From P to F, just this little bit here. That actually gets a little bit trickier. But if we take a look for a moment, I'm going to have to redraw this to make it a little extra clear. I can turn this into a right triangle. I have to add a radius. So let me take this triangle out for a second. Just take a look for a second at what I built. This is 12. Okay. And you might say, well, now what? Well, look, the radius is 13, so that meant this was 13. It also means this is 13 right here. Any radius I were to draw would be 13, right? 13, 13, and so on. So if this is 13, you can go do the Pythagorean theorem, or you can realize that this is a 5, 12, 13 triangle. So that makes this little segment here, PF, 5. Lastly, how long would FL be? Well, if this piece is 5, but the whole thing is 13, again, because it's a radius, then what you can say is the P to L is equal to PF plus FL. And if P to L happens to be 13 long, because it's a radius, P to F happens to be 5, then you can see FL right here is going to have to be 8. A little bit of algebra, and you are good to go. There are your 3 relationships. Good luck.